Hi folks, and welcome to my homework assignment for episode 112 in Paul McWhorter's series on how to get the most from your Raspberry Pi Pico W. And Paul has been teaching us a little bit about PyQt5 and writing desktop applications using PyQt5 to generate GUI front ends for programs that communicate over the network, Wi-Fi specifically, to applications running on the Pi Pico. After the last episode, he said, go wild, do some freestyling here, and figure out what kind of GUI you could write to control different types of hardware that we've learned about. Well, it just so happens that I've been building a power monitor, that is a mains power monitor, and had written a desktop program to kind of control that and pull information back from that circuitry, but did it in a rudimentary terminal-based text mode kind of UI. So why not adapt that UI into a PyQt GUI and demonstrate that? So that's what I did. A little bit about the circuit real quick. And I have a KiCad or a KiCad circuit here. KiCad is a great program if you haven't used it to make your own printed circuit boards yet. The fundamental thing that I'm trying to do here is just understand when mains power has dropped, and then when it has dropped, kind of start keeping a log of what my, how long it's been dropped for. When did it return, if it did return? Did it go back out again? What did that on-off profile look like? And when power is off, to kind of every 5 minutes log what the battery voltage, the backup battery voltage, looks like. So when VBus, which is fed by USB power, drops out, we're sensitive to that, and at that point in time, one of the backup battery sources that you might have plugged in will be supplying the Raspberry Pi Pico over the VSys pin. Got to make sure you diode or something in that isn't already protected or sensitive to the VBus voltage. So that's exactly what I do here to make sure that we don't backdrive the battery pack. In any case, when VBus drops out, the alternate source powers the circuit on VSys. I want to measure the VSys voltage through this resistive divider here. I want to make sure that I don't exceed the 3.3 volts on the ADC input. I've done that before. The Raspberry Pi does not like it. I ruined one that way. In any case, you got to account for the scaling of this resistor divider in your software, which is not too difficult. There's an OLED header here so that we can kind of see what's happening locally on a OLED display. And there's also a DS3231 connection for a real-time clock. Right? I'm not relying on the real-time clock in the Raspberry Pi Pico. I'm using this external one instead. And there's a push button here because I want to be able to tell the Raspberry Pi Pico when I want to go into server mode and I want to talk to it with the application that we're about to see. And there's also a power loss LED and header here. In the example, I'm using the onboard LED because this isn't installed, right? I don't have it in a box yet, but that is the goal. All right, so that's the circuit, and let me change real quick so that you can see the demo hardware itself. All right, so what we'll do is we'll first start up the Pico by powering it on, and then I'm going to turn the battery back up on after that, and then we're going to fire up our PyQt UI. All right, so we plug 5 volts in here. Give ourselves some battery voltage. The message says, hey, if you want to go into server mode, you've got 10 seconds to press the button. So if I press the button, it's going to connect, hopefully. Give you a little message there. As soon as it says it's connected and serving, there we go. We can then fire up our Qt app. Okay. And the PyQt app is pretty straightforward. A couple of different elements versus what Paul has shown us so far, but nothing that's really too difficult to grasp. One simple thing is using a QFrame widget to draw this horizontal line for just visual separation, and another one down here. And I think more importantly, this text edit box here for displaying the log file information that you might want to pull from the Pico after a power down event. All right, so let's see what we have. If I press the status button, I get a message back from the Pico that says, hey, no power down has been detected and I'm ready for more. Let's see, I can get the log, and here's a log from the last time I kind of generated some artificial power down, power restored, power down, power restored. So, all right, there's the log, and it's printed nicely. If I want to clear the log, I can clear the log, and then if I get the log, of course, there's nothing in it right now, and momentarily we'll change that. And then the last thing I can do here is set the real-time clock. And when I set the real-time clock, I go out over the network in this desktop application. I get the year, the month, the day, the date, the time, down to the second. I get all that information and I package it up in a new command. I send that command to the Pico. The Pico digests it and sets the real-time clock, the DS3231, on the Pico. So let's click set. Here's the command that I construct after reading that from the time, the day, date, time from the network. And here's the message that the Pico sent back. It said that we have set that to the current day, date, and time. That's pretty awesome. And then when you're all done here, you want to take the Pico out of server mode. So you hit exit, and you'll see that the Pico actually has come out of server mode and has gone into its normal duty of monitoring the power. And power looks pretty good. VSys is at 4.9 volts, and really that's the 5-volt supply that I'm feeding it, less the diode drop, the Schottky diode drop that's on the Pico itself. That diode ores it onto the VSys pin. All right, so we're done with this for now, so I'll close it. And that closes everything down on this side. All right, so let's cause this to do some logging. So everything is fine right now. Power is on. It has not seen a power down event. So if I unplug the power coming in from the USB, it will sense that. Now it's going to start reading. It's reading VSys, but it knows it's the battery voltage, the backup battery voltage coming from this battery carrier, that it's no longer coming from VBus. And now every 5 minutes, it's going to log what the battery voltage is, what the time, the day, date, and time is as well. And it's going to log all of that locally to the flash on the Pico. And also you'll notice the onboard LED is blinking. As soon as the first power down event is sensed, it's going to blink that so that you visually from across the room will know, oops, our power has dropped out. Okay, that's fine. If I plug it back in, it'll know that it's been plugged back in, power's back on. That causes another log event. If I unplug it again, we've lost power. All right, cool. Now we've unplugged it, or plugged it back in again. All right, I'll unplug it one more time, and then I'm going to turn the battery power off just to shut the Pico application down. And now we're going to restore it and take a look at the log. And I think that will be the last thing that we do here. All right, so it's all set up again. We'll hit that button so that we connect as a server. As soon as that's connected, we can rerun our client again. And now on the client, we can get a status, and we can get the log. All right? These are the last items. Let's clear the log, get the log again, and we're good to go. All right, so that is the demo. Let's exit that and turn the Pico back into its normal job. I can close this. I mentioned that there were a couple of new widgets here. They're really not hard to kind of implement. If I can find them. Here are the Q frame widgets for the horizontal lines. Just got to set the frame shape to be H line, and now you can add, in this case, H1 and H2 appropriately in the stack up or the layout. See, I've got label, horizontal line, the button label, then the button box layout, which has all of my buttons in it. A couple more labels, another horizontal line, a label for the log box, and then the log box itself. And the log box is this Q text edit widget. And I set that to read only. so that a user can't come into the text into that text box and type in text. It's only meant to display the text that I pull from the Pico through the get log command. All right, and then I think in the button handling functions, of course, we've got to do a couple of things that are a little bit different, right? When they press the set RTC button, I've got to go out and grab the latest date and time and construct that in a particular way, and then generate this command string that you saw before. And that's the command string that I will send to the Pico. And what else? Not the clear log. Clear log is pretty straightforward. When somebody selects get log, then I know that, well, a couple things. I'm going to open up a text file on my PC because I'm going to copy that log to pdmlog.txt on the PC. And then I'm also going to continuously read messages from the Pico until I see an end of file message that I've tucked into the very end of the log, always. And then for each of the chunks of data that I've decoded, I'm going to insert that into the log box using the insert plain text function. And it's kind of as simple as that. In any case, a lot of fun as usual. I hope you guys found something interesting to do. I'm sure that it will have inspired a lot of creative responses from you guys. And we'll see what Paul has for us next. Thanks a lot, everybody. Bye.